Everybody on the first example. All right, the only difference, like I said, last time it was arithmetic. Do you remember how we had a common difference? How many remember what I'm talking about? And we took a term and subtracted backwards, right? All right, now we have what's called a common ratio. It's on your paper there. Now, and that's called R, obviously, ratio. So if we were going to do that, let's look at the first example and see how we'd find it. We have 1, negative 1/2. Does everybody see where I'm talking about? Okay. Now this is a common ratio, and it works with all of the terms. Like I could pick any term, any place in the sequence and subtract backwards, or excuse me, we're not subtracting now, we're doing a ratio. But here's what you do. You take the term and put it over the one behind it, because a ratio is a fraction. So you put negative 1/2 over 1. See what I did? Took this term, put it over this one. If I did 1/4 over negative 1/2, I'd get the same thing. Common ratio. Now, of course, that's going to equal what? Negative 1/2. So the R for that is negative 1/2, the common ratio. Now, remember last time if I wanted the next term, what did I do with the common difference? Added it to this, like I would add it to this one. Well, if you want the next term in a geometric sequence, you multiply by the common ratio. So if I want the next term after 1/4, you take 1/4 times negative 1/2, and we would get, okay, so that would be the next one, wouldn't it? Bless you. And then if we wanted another one, yes, you multiply by negative 1/2 again, and the next term would be positive, wouldn't it? 1/16, right? Does everybody follow what I'm doing? So that's how you can get terms in a ratio, excuse me, in a geometric sequence with your ratio. You multiply. All right. Now let's go down to example 2, part A. Here's the next formula that was similar to the one. This is on your paper. Remember the other one we had a sub n equaled a sub 1 plus n minus 1 times d. That was for arithmetic. For a geometric, it's down right below example A. It's real small there. To the right side under the, okay. For geometric, you'll still know all of these terms because you used them in the last one. A sub 1 means what? First term. So let me erase this so we can do the one that's on this problem. So what is the first term in this sequence? 256? Yes. And what's next? Negative 179.2. Thank you. Is it positive? Oh. My mind was faster than my hand. 179.2. And then what do we have? Now, again, this is a, goes on forever, right? Okay. So if we want to find a term, I think here, don't they want the 23rd term? Yeah. So remember, this is how you would write it. A sub 23 equals, we know the first term, a sub 1 up here, would be 256. And then we don't know R yet, so we need to figure that out. Remember how we found it before? I just showed you how to do it. Take a term and make a ratio with the one before it. So you could take negative 179.2 over 256. Actually, go ahead and divide that since we're doing decimals. Tell me what you get. Negative 0.7, yes. Take this divided by this. Well, the only time I leave it in fraction form is if some of the numbers in the sequence are in fraction. They don't use decimals. But here they're using decimals, aren't they? So we can do it as a decimal. We can go ahead and divide it. So you got this divided by 256, the previous term. And that should come out to negative 0.7. Is everybody okay with that? So that's our R. That goes in for R in the formula. Now, how did you know what N was? So what is it in this case? 23, right? Aren't we trying to find the 23rd term? It's the number of the term. So here we're going to have 23 minus 1. Now, the only thing you have to worry about is knowing how to run that through your calculator. Order of operations says you do exponents first, don't you? Not times to the 22nd power and then times 256. Then you're doing it wrong. You're putting it in wrong. You should take, first of all, this is going to be 22 right here, isn't it? 23 minus 1 is 22. You need to take negative 0.7 to the 22nd power times 256, and it should round approximately to 0.1. Now, do you notice in the directions when it says approximation? The reason is if we're rounding, you know that's not exact, right? Anytime you round, you're finding an approximation. Now, is there any questions on how to do this formula? It's not hard. Yes. Well, yeah. I should have done that. Either write the words or you can write it like this. As Kadisha said, remember this? Have you seen that before? For approximation. Shouldn't come to a negative. Probably because you didn't put parentheses around this or something. Because if you take a negative anything to an even exponent, shouldn't it be positive? Yeah. Now that's how you use this to find a term. Okay with this? Yep. In other words, that's going to be the 23rd term in this sequence. If you kept multiplying by negative 0.7, you'd get to 0.1 when you got to the 23rd one. All right, we need to do some more stuff here. You all with me so we can go on now, right? You do or you don't? Okay. If you're having trouble on your calculator, we can figure that out later. As long as you understand the formula, that's what's important. All right, let's go to example 4 on the next side at the top. All right, this says find the geometric means between these two numbers. How many means do they want? So remember how we did the blanks when we were doing the arithmetic? Everybody remember that when we did the arithmetic? We want two means, two numbers between these two. Now when we did arithmetic, we found the common difference and then added it to this to get this one. Remember that? And then added it to this one to get the next one. So guess what we need to find first in a geometric? A common ratio. And you know how to do that, don't you? Okay. Well, the problem is we got to use our formula again. Except we're going to have to solve for R. Do you remember how you did that with the other one? You took this last term, didn't we? Put it in for A sub n. I'm using this formula again.
Why would that be A sub n?
Because that's the last term, and that's what we did when we did. It's always the last term. A sub n is always the last term when you're doing this. And in this case, what is the number of that term? What would n be? 4. Aren't there 2 between here? 1, 2, 3, 4 terms. It's the 4th term. Isn't it? It's the 4th one up there. So the first term, though, is 48, right? A sub 1 is 48. We don't know what R is, but we said n is what? 4. So we take n minus 1, which is 3. Now, is everybody with me on where I got everything? How many terms? Yeah, A sub n is your last term. N is how many terms? It's the 4th one. Is everybody okay with that? Now, do you know how to solve for r? How many know how to start this solving? Well, we want to get r by itself. How is the 48 connected to it? So you divide, right. So take negative, when you divide to get rid of 48, if you want to solve for r. So what do you get when you do that? I get, what? Well, you need to use all the decimals because it comes out even. Don't round that off because it comes out nice and even. You don't throw away decimals. Doesn't this come out exactly that? Yes, it does. Why would you throw them away then? You only round on repeating decimals. You don't round on exact decimals. All right. That's still equal to r to the third, isn't it? We still have that there. So how do you get rid of a cube? There you go. So take the cube root of this in your calculator, and you have r. Yes. If you're having trouble with that part, don't worry, I'll show you. That part's not hard to figure out. Eventually we'll do that. But when you take the cube root of both sides, say it again, is it negative 2.5? Now we've got our r. What did we spend all this time doing that for? So we can find these two means. Yeah, find the common ratio so we can find these. So what do we do to find the next term in the means here? Multiply by negative 2.5. We're not doing arithmetic here. We're doing geometric. So you multiply. In arithmetic, you add. All right, you understand we're talking about a different type of sequence here. So what do you get for that part? True. Positive, right? And then if you took negative 2.5 times 300, you should get negative 750. Are we okay with this now? Yes? Well, we only have one more thing to do, and I'm done teaching PreCal 2 for the year. Too much. All right. The only other thing we did with arithmetic that we haven't done with this is, bless you, is sneeze. Then we haven't done the sum for this yet. Remember how we did the sum formula for arithmetic? Look at the bottom. Well, actually, example 5, part A. There's your formula. But when I copied and pasted, I forgot to take something out of it, so you're going to have to mark out the -1 up by the end. I was copying and pasting, and I forgot to do that. It should be a sub 1 minus a sub 1 times r to the n, not n minus 1. All over. Yeah, take the -1 off this exponent up here and just leave the n. All over 1 minus r. Now again, all you do is find what you need to plug it in and run it through your calculator, work it out. So let's try one here. Part A. It says find the sum of the first 10 times. Oh, this is nice. Because we don't need the last term, do we? Remember how on the other one we had to get a sub n? On this one we just need a sub 1 and r and n. Well, n is going to be 10, isn't it? Are we finding 10 terms? What's a sub 1? So we got s sub 10 because we're finding 10 terms, the sum of 10 terms. The first term in the sequence is 16. Actually, this is a series because it has minus and pluses. Minus 16. Do we know r yet? Oh, got to find r. How do we find r again? Okay, so what would it be? I think it's going to be negative 3, isn't it? Negative 48 divided by 16? Negative 3. So this will be, and that's raised to the 10th power because n is 10, right? All over 1 minus your r. What's 1 minus a negative going to do? It's going to become plus a positive, won't it, when you do that? Now, I'll give you bonus points if you can figure this out. I found the numbers and plugged them in. See if you can work this through your calculator and get your answer. Your exponent key is either a caret key, right there it is. It's the upside down V. So you put -3 in first, and since it's negative, you need to use parentheses.
Oh, shoot.
And then to the 10th, hit equals. I can't, I'm hooked up here. Sorry. We'll just pause your learning for a little bit. All right. Anybody got an answer? Well, let's see. We got 16. Well, let's do something here. Somebody give me this number right here. I know most of you just run it straight through your calculator, so you don't have any way of telling whether you did it wrong or not. 16 times -3 to the 10th.
I got -9.47.
Minus, it's not going to be negative. All right, again, I'm raising a negative number to an even power. It's got to be positive. You need to put parentheses around your negatives when you do this.
Oh, I didn't. I put it all the way through.
Okay. So what's 3 to the 10th going to be? Somebody help me out. What is that number? 5904? 59049. This is all over 4, isn't it? Now you could run that straight through your calculator. 16 minus this divided by 4. Oh, you haven't taken that times 16 yet? Oh, then you can't do that yet. You need to take, well, if you know how to do this, you can make this negative 59049 times 16 plus 16, if you know how to do that. Let's see what you get. Should be a negative answer. No, I don't have that. There it is. -236,192. Anybody get that? That's the answer. Okay. Well, if you're having trouble running through your calculator, that's easy for me to fix. It's up here on the board. This is correct. Okay. If your numbers are off, we can go through it together if you want me to take your calculator and show you how to do it. All right, that's all I need to do. If you got there, got that, give you 2 bonus points if you got this answer. We'll have to look and see how you punched it through your calculator.